What is a factor? Today we're going to talk about the factor theorem, and we want to look at what it means to be a factor. A factor is a number that divides evenly with no remainder. So for example, a factor of 12, or factors of 12 are 2, 3, 4, 6, 12, and 1. Those are all factors because they divide evenly into 12. Well, polynomials and binomials can be factors of other binomials as well, and that would mean that they divide with no remainder. So the factor theorem states a polynomial f of x has a factor x minus k if and only if, I don't know if you remember that double F, that's if and only if. I don't need two F's on that one. F of k equals 0. So that means when I substitute k into f of x, the answer is 0. And so we can use our synthetic substitution to do this. That's a quick way to actually divide and see if there is no remainder. And that is why synthetic substitution works. Okay, so the first thing is to determine is it a factor? The book is going to just say determine whether x plus 3 is a factor of, and then it's going to give you a polynomial, 2x, f of x equals 2x to the 4th plus 10x cubed plus 11x squared minus x plus 6. So determine whether this binomial is a factor of this large polynomial, and we can use the remainder theorem to do that. And the factor theorem, we're going to use synthetic substitution. So if the x plus 3 is x minus k, k is equal to negative 3. And we did that with synthetic substitution. K is the opposite. Okay, and so we're going to put negative 3 into our box. And we get k, and then remember we write down our coefficients and we put zeros for any term that's missing. So if the exponents don't go consecutive, then you need to put a 0 in for the missing one. So that's 2, 10, 11, negative 1, and 6. Then we draw that line with the space. And then this number here is our remainder. And so if the remainder is 0, then it's a factor. So remember we bring down the 2. And we multiply the 2 times the negative 3, and we get negative 6. And then we add 10 plus negative 6 is 4. Then we multiply again, 4 times negative 3 is negative 12. And then we add 11 minus 12, or plus negative 12 is negative 1. Then we multiply again, negative 1 times negative 3, so we get positive 3. And then we add to get 2, and then we multiply 2 times negative 3, and we get negative 6, and then we add, and we get 0. So yes, x plus 3 is a factor. Oops. Okay. So we're going to determine if, and see, it might look like this in the book. F of x equals x to the 4th plus 3x cubed minus x minus 3, and then it might just have the little factor after it, x minus 2. So, because the instructions at the top will be like determine if the factor, or if the binomial is a factor of the polynomial. So again, my k here is positive 2. It's always the opposite sign there with synthetic substitution or synthetic division. And I'll put my 2 in there. And now notice my exponents. They go 4, 3. It's missing the 2, right? And that's a 1 and that's a 0. So it's missing the 2, so I need to put a 0 in there. So I have 1, 3, 0 for the missing x squared, negative 1, and negative 3. Okay. And then we're going to bring it down. That's not what I wanted to do. We're going to bring it down. 1. 1 times 2 is 2. Then we're going to add. 3 plus 2 is 5. Then 5 times 2 is 10. We're going to add. 0 plus 10 is 10. 10 times 2 is 20. Negative 1 plus 20 is 19. 19 times 2 is 38. And 38 plus negative 3 is 35. So because this is not 0, x minus 2 is not a factor. Now the next thing is given a factor. So I'm telling you that this is a factor, then I'm going to factor the polynomial completely. So the problem is going to say, show that x minus 2 is a factor of f of x equals x to the 4th minus 2x cubed plus x minus 2, then factor completely. Because if it's a factor, that means it divides evenly, and we can maybe factor what's left. And that allows us to solve polynomials of higher degree that we can't initially factor. So the first thing we're going to do is show. We're going to do that by the synthetic division. So put in the 2. My coefficients are 1, negative 2. Again, it's missing the x squared term, so I'm going to put in a 0, and then 1 and negative 2. Now when it says show it as a factor, that means it is a factor. So I need to get 0, otherwise I did something wrong. So we're going to bring down the 1, and then we're going to multiply. 1 times 2 gives us 2. Then we're going to add, and I get 0. And 0 times 2 is 0. And then we're going to add again. I get 0. And 0 times 2 is 0. And then we're going to add. And then 1 plus 2 is 2. 2. And then when we add, we get 0. So yes, it's a factor. Well, it told us it's a factor, and then it wants us to factor completely. So remember when we did the long division before Thanksgiving, it was our final answer. We had to put in our exponents here, and this starts backwards. I like to start backwards. This is our remainder. This is our constant. This would be our x. This would be our x squared, and this would be x cubed. So my polynomial is x cubed plus 1, which means that so far x to the 4th minus 2x cubed plus x minus 2 is equal to x minus 2, that's my original factor, and then times x cubed plus 1. And now I need to factor completely. So I need to factor the x cubed plus 1, and this is a sum of cubes. And remember that formula is a plus b, right? A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So in this case, this is x cubed plus 1 cubed. So my a is x and my b is 1. So that's x plus 1 times a squared, that's x squared, minus ab, that's 1 times x, minus x, plus b squared, that's 1 squared, is 1. And then the rest of my factor is x minus 2. So that's my final factorization. Remember that a difference of cubes, that polynomial, it cannot be factored, because there are no numbers that multiply to positive 1 and add to negative 1. So I'm never going to factor that second polynomial, that quadratic, that comes out of a difference of cubes. Let's do another example. Okay, and then our next example is show that x minus 6 is a factor of f of x equals x cubed minus 5x squared minus 6x, and then factor completely. So we're going to do our synthetic substitution. This is the show part. We're going to put positive 6. We're going to copy down our coefficients, 1, negative 5, negative 6, and 0. It's missing a constant, so you have to put the 0 there. And then I bring down the 1. 1 times 6 is 6. Negative 5 plus 6 is 1. 1 times 6 is 6. Negative 6 plus 6 is 0. 0 times 6 is 0 and 0. So yes, that's how we show it's a factor. And so far we know that it's x minus 6. And then remember, this is our constant, this is our x, and this is our x squared. So we have x minus 6 times x squared plus x, and then we can factor the x squared plus x. I can take out a common factor of x, and I get x plus 1. So when we write it down, we're going to write the x first. We don't ever put the x in between parentheses. X minus 6 and x plus 1. Or x plus 1, x minus 6. This is our completely factored. So remember, this x minus 6 is our factor, and so it has to be included in our complete factorization.